A recap of the Edge AI conference day one. It's a conference in San Jose every year and talks about AI from the perspective of the edge. So, under the constraint of energy, particularly. So, how can we get more efficient inference and to some extent also training, but particularly inference? This is the main topic of the conference, and the idea here is that we have uh, since GPT came out in 2022, we have this massive scaling up of models, particularly through Nvidia hardware, and there are lots of startups and lots of endeavors to make that process more efficient. And the main sort of fight or the demarcation line is between how much dedicated hardware do we want versus how much general hardware do we want. And when I listen to these types of conferences, this is similar to the ML Systems conference that I attended a couple months ago in Santa Clara. Like the academic and business communities are fighting tooth and nail to make AI workloads more efficient, but they're running against a Goliath of Nvidia, which has a solution for general purpose compute with acceleration. And the most startups that I've seen at the conference today and the presentation that I've attended, they're all going in the same direction, which is we want more flexibility, we want more adaptability for very specific use cases. And uh, there's one company, SambaNova, which I think is interesting. I want to point them out because they are on the same, they're sort of on the heels of Nvidia by offering flexibility, adaptability, and generality in a much more efficient way. So I'm going to talk about three things here. First, I want to talk about SambaNova. Then I want to talk about some ideas that just were floated around in terms of, let's say, Cadence. Had a person presenting from Cadence how to develop software in an environment where we want to capture all possible models in the software 2.0 framework and then adapt it to specific hardware. For example, how do you translate Python code most efficiently into C++ code if that's necessary, but then also maybe into other types of frameworks that are necessary for most efficient inference. And then I also want to talk a little bit about what I think Tesla did, because they have invested quite a bit in inference. And the problem with inference is that you have these gigantic models that are trained on lots of data, and they have to be very efficient when they do inference by not going to query the model all the time. They have to be able to find the most interesting parts of the model that are necessary for the specific part of sort of the action space that the input data refers to. This is not even on podcast. It's September 10, 2024. This is Crintelco. Since the last update, we're up 7.5%. The market is up about 1%. For the year, we are up 7.6%. The market's up 15.7%. We're underperforming by 8.1%. So Edge AI conference in San Jose this year. It's always an interesting conference because this is a good, when you have a large constraint like Edge AI has. Edge AI is constrained by power. You have lots of interesting innovation. You have lots of interesting people. You have people from software and hardware that are combined looking at solutions for this particular problem. So let me start with SambaNova, a company that is co-founded by Chris Ree and others from Stanford, CEO'd by a person that is also a Stanford grad, but has worked for Oracle for about 2 decades almost. And let me say off the bat, I think the company is interesting from a technological perspective. I think it's managed very similarly to Oracle, which is not a surprise. The CEO comes from Oracle. So there's a lot of talk, very little say lots of posturing, lots of bragging, and when you point them down, when you pin them down into questions that matter, they evade them. So this is my sort of big picture overview. Respect for the tech, questionable management and execution. Now, what am I talking about? Let's talk about the tech first. So the most interesting thing is they're actually using a spatial data flow model in their chip design. So this is not von Neumann architecture. This is data flow architecture. This goes way back to Onur Mutlu. So this is first. I think this is the first time I've seen a large-scale commercial product with data flow architecture. What is data flow architecture? Think about it this way. Instead of having instructions constantly telling an arithmetic unit to do the math, and then you move data back and forth and move it to SRAM and move it to high bandwidth memory and move it to DRAM and then constantly try to manage the caching and things like that. You have data flow is you do the compute as the data flows through the system. Now, for that, of course, you need to have a configuration. You need to have the flow going in the right way. So there's a certain graph model which is being used. The way I understand this is that if you have a data flow model, let's say for inference, what you're going to do is the data comes in, and then the system will configure based on the data that it recognizes, and then do the math as it goes through the system. So there's something like that. They have an RDU, an RPU, a reconfigurable processing unit. So that is basically what they're talking about here. So instead of GPU, you have an RPU. It's more efficient because it doesn't do, it's really memory efficient. This is the key. I spoke with one of the guys there, software product manager or something like that. And he told me that the key to SambaNova is really the memory architecture. Now, look, I think what's interesting about data flow models is that they really lend themselves to software 2.0, right? Because you want to have a system that is highly sensitive to the data that's coming in. And you want to have the system do compute as the data requires it. So data flow models have that kind of characteristic, and therefore I think they're interesting. So that's I think that's the most interesting thing as far as I'm concerned about SambaNova. Now they're very good at we're better at this benchmark, we're better at that benchmark. Some critical questions were asked. For example, okay, how are you really when it comes to how many customers can you serve at the same time concurrently? How many tokens per watt or tokens per dollar can you produce in conjunction with the concurrence of customers? Varun, the guy I spoke with afterwards in the booth, gave me a little bit more context here. So it's maybe not as many concurrent customers, but higher throughput. So you can have maybe less concurrence, but higher serial parallelism. So that's one thing. Price, of course, is relative in this space because you're not really buying software or hardware. What you're buying is solutions. But overall, I think it's an interesting company. On the negative side, I would say the CEO talks a lot, doesn't say much. Lots of bragging, lots of posturing. So lots of Oracle type approaches towards management. But that's okay. I mean, Oracle's doing well. And it looks like if you have a good technology and if you capture a customer, you can actually do well. So what else did I see at the conference? I think there was a VC there, spoke about sort of the general landscape. It was pretty broad. I think it's pretty much everything from foundation models to hardware, more efficient hardware, interconnect switches, optical switches. So there's really, the whole stack is being covered by VCs, and I think that wasn't really very interesting. I asked him the question, okay, look, you're doing all of this, but Nvidia's capturing all the value. How do you reconcile that? And the answer was, I would say, relatively weak on that front. So there was a person from Cadence, though, that I thought it was interesting. He spoke about the necessity to have a sort of flexible software and compiler architecture that takes in different models and then translates them into different hardware infrastructures. And what that means is that, look, you could have a future of, let's say, agentic systems that pulls data first, that is very flexible in the kinds of tasks it can do. So, for example, you could have a robot, an agentic robot that can help you open the door, drive you somewhere, or carry stuff from A to B, help you maybe charge the car, or all kinds of different things that need to be done. And that robot needs to be able to access lots of different models that help it execute the tasks at hand. And therefore, you need to have a certain translation from the model space into action space. For example, if the model space is written in Python, the action space in C++, of course, those are low-hanging fruits. I'm sure they're being solved. But I think overall, the problem is there, and the person gave a relatively technical presentation where there's always solutions, like sort of libraries can be, so you can sort of access libraries and then translate your specific data flow into sort of a function that transforms it into a more standardized data flow. I think that's kind of where this is going, and in my opinion, very interesting. This conference is very infrastructure driven, so it's very deep infrastructure, if you will, and therefore there's not much to say about, let's say, long-term vision or things like that. It's much more nitty-gritty. How can we get more out of the current systems? But here's my conclusion. My conclusion is that the whole industry is chasing, it's almost like they're fighting yesterday's war, because what everybody's doing is, with the exception of SambaNova, I think SambaNova is the first time I've seen somebody who is credibly delivering something that could potentially beat Nvidia. And here's what I mean. Like, what most people, particularly the dedicated people, the dedicated sort of community, we need, special systems with, highly optimized for large language models, highly optimized for robotics, highly optimized for this, highly optimized for that. They're chasing yesterday's war, because what they're delivering is solutions for existing workloads, and that's fine. And there's probably a market for that. But what we need is, of course, a system that is able to adapt on the fly to new models, new data structures, and new workloads and new problem sets. Because all these things are intertwined, right? You have, let's say, multimodal transformers. That's a different type of transformer than the language transformer. That requires a different type of data flow, different type of memory management, and different type of inference. Multimodal could mean multimodal in terms of data input, so audio, vision, language, but also output. I have physical output, I have language output, I have sound output, I have vision output, I have different constraints when I'm in 3D versus I'm not in 3D. So there's a lot of flexibility required by the models. And the reason Nvidia is a leader in the space is because with their current generation and the Hopper architecture and the future Blackwell, they are doing what has been working the best, which is they help you keep a general large data-driven model intact in a way that you can adapt it to different workloads, different data structures, different solutions, different problem sets, and you keep the token per dollar as high as possible. In other words, the efficiency, given the size and the possibilities that you have, is high. I think one big mistake that I've seen across the board has been that people, for example, they say, well, a GPT query is, I don't know, 20 times more the energy consumption than a Google search. Yes, but what is the result? What is the cost saving or the improvement in performance of the actual person that is using that? If I can save myself a worker or a secretary or a developer by using ChatGPT or Llama or something like that, well then maybe I can actually spend more energy on that particular inference set because I'm saving an employee, I'm saving 365 days of commute and all that kind of stuff. Now, of course, this is now almost getting philosophical, but my point is that we need to see the big picture, which is what is the purpose of AI? The purpose of AI, in my opinion, is to make to open up the action space of humans. Whether it's individuals or companies, they can do more with lower cost and serve their customers better, whether it's in better products or lower cost products or both. And that needs to be taken into account when we do all these energy calculations and things like that. Now, having said all of that, now the question, of course, is, okay, do we have competition for Nvidia or don't we have competition? Now, the whole Edge AI conference is basically a conference about companies and startups and established players. The company sponsored by AMD, by Intel, Qualcomm. So, of course, they're all after Intel, after Nvidia. Of course they are. And that's fine. That's how it's supposed to be. It's always been like that, right? Since the IBM days, and then Microsoft days, and then Google days, and now Nvidia days, the big player always is being attacked from everywhere. And the question for Jensen and co is, of course, how can we compete in this, in this ecosystem? For example, the VC, his whole portfolio is basically the Nvidia stack. Every part of the stack is being attacked by startups. Optical switches, Ethernet substitutes, or InfiniBand substitutes. Everything. Tomorrow, I think the afternoon session is all going to be about interconnect, high bandwidth memory, DRAM, DDR, SRAM. All of these things are being attacked, of course. Better solutions. SambaNova has a solution, let's say, where you have high bandwidth memory, but then you have also different other types of memories that are, attached to the dataflow chip, to the chip, which is based on dataflow model. So you don't have a lot of back and forth. So the solution to the memory capacity problem here is that you don't have a lot of back and forth. So the data flows, and therefore you can save yourself a lot of energy and also a lot of hardware costs. So the question, of course, with all of this is, fine, we can have more dedicated solution in specific areas of the stack, but how do we keep flexibility? How do we keep the cost down per token if we dedicate ourselves? This is going to be the fight. And I don't think there's a clear winner on both sides. We can't say Nvidia is winning and the others don't have a chance. We can't say that the others are winning and Nvidia is losing share. I think also the pie is growing, of course, which helps everybody, including, let's say, Oracle, which is yesterday at the earnings call. So there's definitely a case to be made for a much, much stronger ecosystem that has better systems, more flexibility, for larger, more data throughput, and at the same time also has more dedicated workloads for specific use cases. Now, as an investor, I think we want to stay with what has been working, which is general and large data. Thank you.